20 minutes I kept. No, it's okay. Let's see what is the question. Shreyuta going to explain this question. So the position time graph for two students A and B returning from the school to their homes are shown in the figure. So xt, one graph is like this and one graph is like this, right? Xavier, this is your doubt, right?
Yes, sir.
Yeah. So they given the position time graph of two students. Okay. Now, the first option they are saying is A lives closer to the school. Now, tell me why, whether this option is correct or not. Shreyuta, you attended it, right? Tell me.
Yes, sir, that is true. Since the distance is less.
Let me just. So this is A, this is B, right? Okay. So what is it is saying? A lives closer to the school. Okay. So see, closer means less distance, right, Xavier?
Yes, sir.
So less distance means what you will see. So this final point is nothing but where they reach the home, right? Correct. So if you check
Yes,
both
sir.
distances, A is taking this much distance, x1. B is taking x2 distance. So who is closer? X1, right?
Yes,
So
sir.
A is correct. Then second, B lives closer to the school, then B is wrong. Then third option is A takes lesser time to reach home. Now tell me this. Tell me this, guys.
So it will be wrong, no?
Which one?
That A lives closer to home.
A lives closer to the home is wrong.
Like
How?
home means it's coming back to the origin, right? So
No, it's not coming back to the origin, right? Wait, the position of two students and returning from the school to their home. No, it is not origin, right? Just let me. Okay, so here we go. Correct only, no, Xavier. See, this the way I explain it is correct only. Okay, because you will see the distance, right? If he is come, this is his home. That means even if you see that way, he need to cover this much and then he need to cover here, right? But
yes,
that
sir.
doesn't make sense. Here the distance you need to see. This is the time axis. Okay. So you need to see the distance means what? You will judge it based on this x only, right?
Yes, sir.
This graph is given x versus t. So whichever the distance is there more, so that you need to judge. Okay.
Okay, sir.
Okay. Next, what was the next third one? Who reaches the home quick? Since what is that? Okay. A takes lesser time to reach home. Correct or not, Xavier?
Yes, sir.
Who will reach the home first? It depends on their speeds. Correct. So slope of B is more, right?
Yes, sir.
Is more than slope of A. Correct. And if you
Yes, sir.
see B's slope is more, that means speed is more. And A's slope is less, speed is less. Now, how much time they are taking? So B was here, right? Initially, it starts from some other time. It is starting. So it is taking this much time, correct? And A is
Yes, sir.
taking this much time. So what is the correct option? B walks
B takes
yeah,
faster. Like
lesser
B
time.
reaches faster.
Yeah, B takes lesser time. Then A travels faster than B. That is wrong. B travels faster than A. That is correct. So whichever the option is there, you take it. Which one you had doubt? One more you said no.
So the third one.
The graph one again.
Yes, sir. I have to practice the graph one. So like I have to
No
be thorough with
problem.
the graph.
No problem. No problem. We'll do now. I'm here. Don't worry. Just you can ping me in WhatsApp also. Okay, Zevan?
Sure, sir.
Yeah. So
I'll do
any
that
doubt you
from
have,
now
I'm
onwards.
here to help you. Okay.
Yes, sir.
So this is the question, right? 0, 5, 10, 15, 20, 25. Then this is 10. Then this is 20. Correct? So
Yes, sir.
velocity versus time graph is given. From the VT graph shown, the ratio of distance to displacement in 25 seconds of motion is. See, what is distance? Distance is nothing but speed into time, correct?
Yes, sir.
Displacement is nothing but velocity into time, correct? So in distance, if for example, if I tell you, you are going from, let's say, A to B, okay? So let's say I'm going like this. So my distance will be, let's say, 10 meter. Okay. And let's say I'm going from A to B, then B to A. So what is my distance covered? 20 meter. Correct. But if I
Yes,
ask you what
sir.
is the displacement from going from A to B and then coming back to A?
That is
0.
0.
So similarly, in distance, we don't see whether the particle is changing its direction or not. It is changing its direction here, right? Correct. But in displacement, we'll see, okay, where is the particle changing its. So we know that if we velocity time graph is given, so the area under velocity time graph gives you displacement. Okay, directly you calculate the area. This is positive area, this is negative area, correct? So here
Yes,
the
sir.
particle is changing its direction. So you get some positive area, let's say A, then you subtract the negative area, let's say A2, then you will get displacement. If you add both areas, you will get distance. That's it. So you need to find this ratio. Okay.
Yes, sir.
In case of distance, we add, right? All we add. But in case of displacement, we need to subtract.
Subtract.
Got it?
Yes,
So
sir.
in case of displacement, we'll go as it is, positive area, negative area. But in distance, we need to add all the areas, whether they're positive or negative. You can solve now, right?
Yes, sir.
Okay. Any other doubts anyone have? You,
Sir,
Shreyas?
could you explain the ninth question? I was able to solve it using the max height formula, but I didn't know how to solve it without a formula.
Two projectiles are projected at 30 degree and 60 degree with the horizontal with same speed. The ratio of maximum height attained by the two projectiles respectively is. One is being projected with 30 degree, correct? Other we are projecting with 60 degree, correct? So same speed, v, correct? So this component of speed is v sine 60. This component is v sine 30. For maximum height, what is the formula here in this case? V sine 30 plus 0 divided by 2 into time, correct?
Yes, sir.
Here h is equal to v sine 60 degree divided by 2 into time. Correct, no? So now, but is it necessary that both of them is going to take same time?
No, sir.
So what you do, since the v is same, right, in both case, you take some value. Let's say we'll take 100 here, and or if you want to do some proper cancellations and all, right, you take 100 root 3. Any value you can take, no issue at all. Okay. So here, if I take like, for example, let me take 100. So what will be this value? 100 into 1 by 2, correct? Sin 30 is 1 by 2. So this is becoming 50. So here it is taking 5 seconds, correct? To
Yes,
reach
sir.
the top. So here 100 into sin 60 means what? 50 root 3,
Yes, sir.
correct? So how much time here it will take? 5 root 3 it will take here, correct? So you put 5 here and 5 root 3 here. Any doubt?
No, sir. I understood.
Just divide. Just divide. 2 cancelled, v cancelled. 1 by 2 divided by root 3 by 2. Here 5, here 5 root 3. Correct? 2 cancelled out. 5 cancelled out. 1 is to 3.
Okay, sir.
No need to use any formulas. Did I use any formula?
No, sir.
Yeah, just this maximum height is equal to average velocity into time. Only this formula I used. Otherwise, you see, you search online this question, okay? You search this question online, you see how the solution will be. Okay?
Okay, sir.
Zevian, you understood this question, right?
Yes, sir.
Yeah, simple it is. Just the time you have to be very careful how you calculate that time. You just put some random value here, pick some random value. Since the even if you don't take the random value, even if you consider v only, and the time depends on this angle, right? Sin 30 and sin 60.
Yes,
So
sir.
here it will take root 3 times more time. So we just kept here root 3 times more. If I take t here, it should be t root 3 here.
I took as 100, so like
Yeah, you can
in
take
the first
100.
class, how we did.
Yeah. So you can take any. You can just even keep it as v. No problem. So
Okay, sir.
you can do it either way. Yeah, anything else?
Sir, can you explain the sixth question, sir?
There are only 5 questions. You are asking the,
I mean the second ones,
yeah. So who is asking this doubt?
Samhitas.
You didn't attend at the test. How you know the question?
Sir, I got the PDFs when I opened it.
Okay. Projectile is projected at 30 degree from horizontal with initial velocity 40 meter per second. The velocity of the projectile at t is equal to 2 seconds from the start will be. This question is simple, Amma. Xavier, you explain this question. We are projecting with 30 degree 40, okay?
Okay, sir.
Per second. Tell me what will be uh, the velocity of the projectile at t is equal to 2 seconds from the start. Yeah, at t equal to 2 seconds, what will be the velocity? Tell me the approach. What will I do first?
So first, like we'll put in terms of sine and cos, like
Yeah.
sine 100.
So this will be 40 cos 30, right? And
Yes,
this
sir.
40 sin 30. So this will become 20. This will become 20 root 3. Okay, then.
Then so like we calculate the time and then we multiply it.
After 2 seconds, what will be the
After,
velocity they are asking, right? So after 2
yes,
seconds, what
sir.
happens to this velocity? How
0.
much it will be? 0,
It
right?
will it will become 0.
Yeah, so in vertical direction we have 0. In horizontal direction, how much we have?
20 root 3.
So that is the answer. They made it very simple. They should have asked at 3 seconds. What will be the velocity at 3 seconds, students?
For the vertical or the horizontal, so?
You tell me both.
So for vertical, like for the y-axis, it will become 10, right? Like it will
Minus
start increasing, minus 10.
And
And then for vertical
for horizontal,
x-axis, it will, for horizontal, it will become 20 to
20,
3 I.
20 root 3. This will not change. Okay. This will always remain same. Okay, guys. It will not change because there is no one to change it. Understood? Samhita,
sir.
understood?
Yes, sir.
Any other doubts you have from any other books? Shreyuta, Samhita, Zevion?
No, sir.
You are practicing?
Yes, sir. I'm practicing. Like I have like one of my board exam is still pending, so I'm like practicing both together. So I'm not able to get that much time for
Oh,
doubts. So,
I understand. When is the exam?
also 2nd April.
2nd April, no? Okay.
Yes,
You do
sir.
one thing, like you in the morning, what time you wake up?
So I wake up around 6.
Are you sure? I doubt.
Yes, sir. No, sir. I wake up at 6. Like 5:36, like that. I wake up.
Okay, no problem. So you divide your time in two halves. See, these two, this now you have to study at least some 10, 12 hours. Okay. So you divide it into 4 and 8. Okay, 4 hours you study physics, 8 hours you give to your exam preparation. Okay.
Okay, sir.
Yeah. All right. So shall we proceed, guys?
Yes, sir.
Yeah. So now we will start a new chapter, Newton's laws of motion. Okay. Now, kinematics, whatever the basic things are needed, whatever the concept is needed, I have covered it. Okay. In the whole kinematic, even the relative motion questions, I didn't do much, but I covered the relative motion concept. What you have to do is just, resolve the vectors into components and use vectors, theorems, vector formulas to solve the questions and basic idea of acceleration, velocities, and all these things and graph things. Everything is being covered. Now we will start with Newton's laws of motion. So along with I will put some assessment and exams and all. So you practice more questions and we can have a discussion like this. So in that way only we can make strong in kinematics. Okay, guys? Any doubt?
Yes, sir.
So Newton's laws of motion, first thing that we need to study is about force. Correct? What is force? Force is a push or pull which changes the position of the body. Okay. And here in this chapter, I will write in this chapter, I hope you guys are also writing along with me. We assume all the bodies to be point object. Okay. All right. So force, when I talk about force, force is nothing but it is a push or a pull. This is a vector quantity and the unit is Newton. Okay. So now when I talk about force, there are four kind of forces in the nature. Can you guys tell me what is the first?
Gravitational force.
Gravitational, magnetic, then there is magnetic force.
Electromagnetic forces, right? And then
Gravitational force.
we have gravitational.
Strong nuclear force, weak nuclear.
Strong nuclear force, weak nuclear force. Now, my question is, let us say you are walking on a floor, right? There is friction is there, right? So friction is a which kind of force?
Opposing.
Or let's say you are eating an apple, you are chewing with your teeth. So which kind of force you are applying? Or let's say you are pulling a rope. Let's say you have tied a rope and you are pulling it from here. So what kind of force that tension is? Or let's say you have a spring, a mass, you stretch this little bit by X amount. Which kind of force is this? Tell me, all these forces are of which kind? If anyone tells, I'll give you some reward.
Elastic.
Don't Google it.
Elastic force.
No, wrong. All these forces are electromagnetic forces. Amazing, right? You are feeling a bit confused,
A little
guys,
bit, sir.
but actually they are. So if you see microscopically, right, when two things are coming in contact, that means see, if I go little bit inside, so if two things are coming in contact, no, so if you zoom it out, what is there? The atoms are there, no? Correct? And they have electrons revolving around them, correct? And then this body which is touching the other body, they also have some electron revolving around the nucleus of the each atom, right? So that is electron interaction. So when two things are in touch, they are bound electromagnetically. That is the electronic lock is happening there. The interaction between the electrons is happening between the atoms of one body to the other body. Okay, so microscopically, if you go and try to observe which kind of nature that particular force has, so we find that they are electromagnetic forces. Okay, now the doubt is resolved, right?
Yes, sir.
Yes,
Okay,
sir.
so just for your information, I told you that. No need to worry much about that. So now we'll study about action reaction forces. Okay, action reaction pairs. So let's say I have a table, or let me just consider earth. This is my earth, and then I am just keeping a object on the earth. Can you guys tell me what are the forces acting on this mass?
So gravitational force and normal force and
Okay, so if I take this body here, gravitational force is acting. Since it is not going inside the earth, there has to be some force which acting on this mass, and that will be equal to the gravitational force, that we call it as normal force, right? So is mg and normal force are action reaction pairs? Xavier, what do you think?
No, sir.
Why no?
Like,
Hmm.
it is gravitational magnetic, no, sir. Mg.
No, it's not magnetic. Gravitational force is gravitational force. Okay, it is not. It doesn't come in electromagnetic force. Normal is electromagnetic force. Okay, I am also telling you that magnitude of mg is equal to normal. That's why the block is at rest on the earth, right? Otherwise, if gravitational force becomes more, it will penetrate and go inside, no? Correct? We are standing on earth.
Yes,
Why we
sir.
are not going inside the earth? See, there is gravity. Why we are not going inside earth? Because there is one normal force which is opposing that. So both have to balance to stay on the earth surface. Correct? So
Yes, sir.
mg and normal are action reaction pair or not? Action reaction pair means the forces which are equal. See, the definition is the forces which are equal and opposite in direction. Opposite in direction. So now tell me, mg and normal are action reaction pair or not? Shrita?
Yes, sir, I think they are.
No, actually they are not. If to just finish this, no one will tell. Okay, even most of the books end this definition here only, but there is a fill in the blank. What is that fill in the blank? Is the forces should be of same nature. Should be of same nature. Xavier, you are almost close. Okay.
Okay,
So
sir.
here, if you see mg and normal, okay, that forces which are equal, that is satisfied. Magnitude of both are same. First condition is satisfied. And opposite in direction, that is also satisfied. Normal is acting up, gravity is acting down. That is also satisfied. But are they of same nature? No, same nature means they should belong to same category of force. Like either they have to be both electromagnetic, both gravitational, both strong nuclear, both weak nuclear. Okay. So in this case, one is gravitational, one is electromagnetic. That's why they are not action reaction pairs. Any doubt?
No, sir.
No, sir.
Yeah. Write down this. Once you are done, let me know. Make a habit of writing your own book. Okay. Should write whatever I'm coming from my mouth. You should listen and write it as it is. You will get to know its importance. Even if you read after 1 year, after 1 month, after 5 days, you will be like, when you start reading the notes, you'll be like, sir is in front of me and I'm listening the class. And your handwriting will also become fast. You will become more quicker. Your comprehension will improve. Should not just sit ideally. Write whatever I'm saying as it is. Okay. Even if I scold you sometimes, you write it in between. That will
Okay,
remind
sir.
you, okay, something has happened in class. Okay, let me go ahead. So just I want to give you brief introduction about this guy, normal force. See, this guy comes in picture when two things come in contact. Okay, two things come in contact. Okay. So for example, let's say there is one block A and other block B. Okay. So if I bring them closer, they will touch each other, right? Then A will start applying some force N on B, that is called normal force, and same amount of force B will apply on A, that is also normal force. Okay. And it is an internal force. All these points you note down. Internal force. And if I ask what is the total normal reaction, then it is 0. Correct? If I ask what is normal reaction on B, it is N. What is normal reaction on A? It is N. But what is the total normal reaction means? It is 0. Okay? They are internal pairs, right? These are action reaction pairs because Both are of same magnitude, opposite direction, same nature. Action reaction pairs. Normal force exists in action reaction pair. All real forces, not only normal, all real forces which you can feel are exist in action reaction pair. Okay, these are very important points. Sometimes we forget these things. Question solving is simple, but if theoretical question comes, we'll be very stuck. Got it, guys?
Yes, sir.
Shall I go to next page? You have written this?
Yes, sir.
Yeah.
Okay. Now, so let us take the same question. This was mass, this was earth, right? So if I take this mass M, now earth and this block A, let's say they are coming in contact, right? That means earth will apply a normal on the block, and same thing, the block will also apply a normal on earth. So these are action reaction pair, correct? And mg is acting on this block. Same amount of mg will be acting on earth at the center of the earth. These are action reaction pairs. These are action reaction pairs, and these are action reaction pairs. Any doubt? If you have small doubt, also tell me now itself. Xavier, clear?
Yes, sir.
Shriyuta, Samhita?
Yes, sir.
Yes, sir.
Okay. This thing is clear, right? Now we'll go to the concept called free body diagram. Put the heading free body diagram. Free body diagram, FBD. So what is FBD is, if I give you a complex system like a truck or I will just give you a truck and I will tell you, well, calculate with what speed the wheel is rotating, or how much force the driver is applying on the brake, then it is very difficult to deal with such complex systems, right? So FBD, what it does is it takes one component of the system and it analyzes separately. So free body diagram means, let's say you have a system. System means anything. Let's say there is a table on which a block is kept on block, one more block is kept, or there is a cat sitting on the table. Now I want to know how much is the force this table applying on this cat. All these things. That means this whole thing becomes my system. Free body diagram, what it does is, in which I'm interested. For example, I'm interested in this cat. I will bring it out. Okay. I will consider it as a point mass, and then I will see, well, so what and all forces acting on this cat. One is acting gravity, mg. Let's say mass of the cat is m. Then one is the force that table applying on the cat. That's it. Now I can easily tell how much is the force that table is applying on the cat. Correct? So free body diagram means bringing the things each, when we break things into steps, it becomes easy for us to study. Understood? Yeah. So we'll start with simple systems. Okay. Free body diagrams. Then we'll see how we can deal with them. Okay. So before I tell you free body diagram, there is Newton's second law. Okay. Second law, which tells that force is nothing but rate of change of momentum, or you can say force is nothing but mass into acceleration. Okay, where this force is the sum of all forces acting. Sum of all forces acting. Okay, for example, there is one block, there are n number of forces acting: F1, F2, F3, F5, dash dash Fn. If let's say n forces are acting on that, so the vector summation of all the forces F1, F2, so on, Fn. So this is nothing but my force F. This one, what I'm saying. This is equal to mass into acceleration, and the acceleration will be the acceleration of this block. Any doubt here?
No, sir.
When we
No,
do
sir.
questions, this thing becomes easy. Okay, but we should study things in general way. So let us take first free body diagram, example 1, with a book and a table. Let's say guys, there is one table. I'm now assuming it has only 2 legs, okay? And there is one book of mass small m, and the table has a capital mass M. Now we want to analyze what are the forces acting on this book and what are the forces acting on this table, correct? First, book. What you will do, you bring the book here separately, then see what are the forces acting. First force is gravity, mg, correct? Then what is the second force acting? Normal. Normal by whom? You should mention that. Normal by table. Okay. So can I say mg equal to normal reaction acting by table? Because the book is at rest. So what is the net force on the book? It is 0 because it is not at all moving. So this is how you can, how I said mg equal to nt, because I'm summing all the forces, right? So mg, if I take plus direction, this, then nt will be minus direction. So I'm just summing this, and all this should be equal to 0 because f equal to ma. A is not there because this block is not moving. That's why I written 0 here. That's why I'm saying mg equal to nt. Okay. Similarly, if I see this table, if I am interested in this table, then the same amount of nt will be applied by the book on this table, correct? And there will be some normal reaction applied by earth on the table's legs. If there are 2 legs, 2 normals, 4 legs, 4 normals. And the table also has some mass, so there will be some gravity mg, correct? So now tell me the table is at rest. So sum of all forces has to be 0. I will take one down direction as positive, up direction as negative. So I will sum all the forces. Down forces are what? Nt plus mg minus ne minus ne. All forces should be equal to 0 because my table is not moving. So from here, nt plus mg minus 2 times ne equal to 0, correct? nt plus mg equal to 2 times ne, correct? And we know from this what is nt equal to small mg. So small mg plus capital mg is equal to 2 times ne. So from here you can get how much the earth is pushing the table with what normal, okay, on each leg. Till here, any doubt?
No, sir.
No, sir.
No, sir.
Xavier, any
No,
doubt?
sir. No doubts.
So you have to see where all the contacts are coming and you need to draw the free body diagram accordingly. Please finish this and I will give you one free body diagram to draw and we can end the class.
Done, sir.
Rest of the peoples?
Done, sir.
Done, sir.
Okay. So the time is up. I'll just give you a homework to draw the free body diagram. Okay. Let's say, okay, I will just, let's say I have a table again, but now I have 4 legs. Okay. And there is one block kept on it and then one more block kept on it. Let's say the table is of 5 kg, then this block is 3 kg, then this block is 2 kg. You need to tell me what is the normal reaction on each leg of the table. Okay, will you get me the answer tomorrow?
Yes, sir.
Yes, sir.
Yeah, please note this down and we can end the class. So, any feedback for today's class? You felt anything difficult or you want me to add anything else?
No, sir, it was easy to understand.
What about you, Xavier and Samhita?
It was easy, sir, today. Not
Okay,
that difficult to understand.
okay, Samhita. But
Yes,
today's
sir.
points, whatever I told you, right? You go watch some other videos, other lectures, you won't get these points. Actually, these are important. Whatever we covered today, you understood, that's great. Please keep these points in your mind.
Yes, sir.
Okay. And attend
Yes,
tomorrow's
sir.
test also and see how you guys will perform because today two people attended, one person faced a problem. So you can contact Chanakya in that case, Xavier.
Okay, sir.
Yeah, there are people who can help you. So you just reach out to them, the technical team. They can help you out to solve that. Okay.
Okay, sir. And so
And
regarding tomorrow's test, I may not be able to write it because I'll be going to school.
okay. So what time you are going?
So from morning till afternoon 3:30 I'll be there. I'll come to attend, sir.
So you can attend after 4, right?
Yes, sir. I'll try to attend it.
Yeah. If you can't attend, just let me know. I will cancel it. I'll keep it next day. Okay.
Okay, sir.
Okay. All right, guys. All the best. See you. Bye bye.
Thank
Thank
you,
you,
sir.
sir.
Bye, sir.